Good morning, students. Welcome to mathematics class with Sir Victor Egenkonye. I believe this is the first time you're seeing me on your platform. Today we'll be looking at basic trigonometric ratios, which is our next topic in our scheme of work. So under this topic, by the end of this lesson, you should be able to, that'll be our objectives, state the Pythagoras Theorem, which I know you're hearing for the first time. Use the Pythagoras Theorem in calculating lengths, and also determine sine, cosine, and tangent of an acute angle. These will be our objectives for this lesson. So now, you'll be hearing the word trigonometry. Now, as the name suggests, as the name might suggest, it's all about triangles. When you hear the word trigonometry, it's all about triangles. But more specifically, trigonometry is about right-angled triangles, where the internal angle there is 90 degrees. We've done right-angled triangles in our previous theme. We all know what, although we're going to revise that in the next slides. Now, trigonometry helps us to find angles and distances. It's very important that you understand this, that trigonometry helps us to find angles, the value of angles, and distances, and is used a lot in science, engineering, video games, and more. So now let's revise what right angle triangles are. Now, right angle triangle has a single right angle. And from what I told you earlier on in our previous classes, that right angle is a triangle that has 90 degrees in one of its angles. So by definition, that means that all sides cannot be the same length. Now, a typical right angle triangle is shown below. From the diagram you have there on the left hand side of the screen, you can see what we refer to as a right angle triangle. Now, from this triangle, there are three sides there. You can see the right angle there, that little box there, the right angle, which has a value of 90 degrees. Then opposite that angle, the side opposite that angle is what we refer to as the hypotenuse. And is also known as the longest side in a right angled triangle. Always remember this, that the side opposite the right angle is called the hypotenuse and is the longest side in the right angled triangle. Now, the side opposite that angle there, that angle theta, we call this angle theta, is what we call as the opposite side. Then the other side there is what we refer as the adjacent, the side next to the opposite side. Now, the right angle is indicated by the little box in the corner, which I've shown you. The other angle that we usually know is indicated by theta. That angle there is referred to as theta. And the side opposite the right angle, which is the longest side, is what we refer to as the hypotenuse. The hypotenuse there. And the side opposite theta is called the opposite. And the side next to theta, which is not the hypotenuse, is called the adjacent side. So I believe you've seen, your brains are refreshed by telling you what a right angle triangle is and what it looks like. So now, going to the crux of today's lesson, which is the Pythagoras Theorem. And the Pythagoras Theorem or rule states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. Now take a look at this triangle you have on your screen here. Triangle ABC, and you can see that it has, the angles are indicated with capital letters there. A, B, you have the side A there, you have side B, and you have side C over here, where you have your right angle there. Then the sides are indicated with small letters. The side opposite the right angle is the hypotenuse, is indicated as C, while the opposite side is indicated as B, and the adjacent side indicated as A. Now you should recall that in the right angle triangle we talked about the hypotenuse side being the longest side in a right angle triangle, and the hypotenuse is always the side facing the right angle. So now let's see what this Pythagoras theorem looks like mathematically. So Pythagoras theorem, which states that the square of the hypotenuse equals the square of the opposite side plus the square of the adjacent side. Now, if you look at this triangle you have here, you can see that the hypotenuse side is C. So we square it, and it's equated to the sum of the squares of the opposite side and the adjacent side. Now, another way to remember this is stating it as hypotenuse squared, which you have there written there literally, equals opposite squared plus adjacent square. Now you need to memorize this formula, but firstly you have to understand the right angle triangle. From this right angle triangle you can see that the side opposite the right angle, that's angle 90 degrees, is C. The opposite side is B, and the adjacent side is A. So from the Pythagoras theorem, the hypotenuse side is squared and is equated to the opposite side B, which is squared also, plus the adjacent side A, which is squared as well. So having understood this formula, let's use it to solve questions. Now, why is this rule or theorem useful? It's useful because if we know the length of two sides of a right angle triangle, we can find the length of the third side using our Pythagoras theorem. Because if you look at the Pythagoras theorem, it involves three sides. C squared equals A squared plus B squared. So, excuse me. So if I know the value of side A and side B, I can use the Pythagoras theorem to find side C. So you can see one of the uses of the Pythagoras theorem. But remember, this only works on right-angled triangles. You can't try this rule or theorem on a scaling triangle or an obtuse triangle. It only works on a right-angled triangle. So now, how do I use this theorem or rule? First of all, I'm going to write the rule or theorem as an equation, which states that C squared equals A squared plus B squared. We all know what C stands for. C stands for the side opposite angle 90 degree, which is our hypotenuse, and is equated to the sum of the squares of the opposite side plus the square of the adjacent side. So first of all, you write it as an equation. Then we use algebra to find any missing value, as in these examples. Now, in the next example, look at this. We're asked to solve this triangle. Now, like I told you in class, that when you're asked to solve, that means you have to find the value of an unknown. So if you look at this right angle triangle, all the sides have values except the hypotenuse. The opposite there has side of 4 units, while the adjacent there has side of 3 units, whereas the hypotenuse side is C, an unknown there. We do not know what the value of the hypotenuse is. So firstly, like we said before, how to use the Pythagoras theorem, we have to state the Pythagoras theorem. Now, stating the Pythagoras theorem, we have that the hypotenuse squared equals the opposite squared plus the adjacent squared. Now you see, we've stated the Pythagoras theorem. This is the Pythagoras theorem. That's the first thing to do here. Or you can write it using your alphabet. That's which indicates the sides of the right angle triangle. So if we are to compare our triangle with the Pythagoras theorem, then consider the hypotenuse there is C. The hypotenuse here is C, so we write it as C squared. We are putting in what we know. So the hypotenuse squared equals C squared. And then moving to the opposite, the opposite there is 4. So the opposite squared will now be 4 squared plus the adjacent squared. Our adjacent there is what? 3. So our adjacent there is 3, so we replace it as 3 squared. So calculating the squares, C squared will remain as C squared equals 4 squared is evaluated as 4 times 4, which gives 16, plus 3 squared, which is 3 times 3, which gives 9. So we've calculated the squares there. Moving on to the next example, we keep on calculating. C squared equals, now when we sum 16 and 9, what do we have? We have 25. And like I told you in class, that whenever you have a number or a variable raised to power 2, we can get rid of that power by taking the square root of that number. So to get rid of this square, we are going to take the square root of C squared. And remember, the rule in mathematics is that whatever you do to the left-hand side, you must do to the right-hand side. So that's why we have to take the square root of both sides, taking the square root of both sides. So square root of C squared will now be equal to the square root of 25. Square root of 25. So the square root takes care of the square there. So what we are left with is C, and the square root of 25 gives 5. So C equals 5. And that means that our hypotenuse has the value of 5 units. So can you see a very useful way we can get this, an unknown side in a right angle triangle using our Pythagoras theorem. Now let's take another example. You can see the triangle here is somewhat inverted. It's all the same. The major thing there for you to know here is the right angle, where the right angle is located. And the side opposite that right angle is referred to as our hypotenuse. So when you can get hold of that, then you're good to go. So in our example here, we asked to find y in this figure below. And also, what's the unknown side here? Also, it is the hypotenuse, because the side opposite the right angle is termed y here, which is our unknown. And our opposite here is 5 meters. And our adjacent here is 12 meters. Now you can see that in this example, the sides are given the unit of meters. So it is very important that you take note of these units. So now, using the previous method in solving this, we have to state the theorem first. So stating the theorem, we state that hypotenuse squared equals opposite squared plus adjacent squared. And from what we have in our diagram, the hypotenuse there is y. So we're going to take the square of it. That gives y squared equals, and the opposite side is 5 meters. So we take the opposites and square it. We have 5 squared. Alright. Then adding it to the adjacent squared. Our adjacent there is 12 meters. So we have it as 12 squared. So having done that, we calculate the squares. So y squared is going to be equals to the square of 5, which is 5 times 5 is 25, plus the square of 12, which is 12 times 12 is 144. So we keep on calculating. Y squared equals, we sum 25 and 144. So adding 144 to 25, what do we have? 169, right? We have 169. So like we did in our previous example, we take square root of both sides so that we get the value of y. Because y is the unknown we're looking for, not y squared. So we have to get the value of y and not y squared. So to do that, we take the square root of both sides. So rooting both sides, we have square root of y squared becomes y, and square root of 169 is 13. Now you can find the square root like I thought. You can use the method of prime numbers, dividing by the prime numbers to get the square root of 169. But I believe you already know what it is even before now. So y equals 13. That means the value of the hypotenuse is 13 meters. Alright, now let's take one more example under the Pythagoras Theorem. Now we have to calculate the unknown side in the figure below. Now look at this diagram here in this figure. Do you think it's a right angle triangle? Yes, it is. Why? Because there is a right angle there. There's angle 90 there. You can see that there, over there. So now, what is the side opposite that angle? The side opposite that angle is 10 centimeters. Very good. The side opposite that angle is 10 centimeters. And the opposite side there from the triangle is x centimeters, while the adjacent there is 6 centimeters. So what's our unknown here? In our previous example, our unknown was the hypotenuse. Y. You can see that y was the unknown here. And in this example, C was the unknown here, also the hypotenuse. But in this example, hypotenuse here is the adjacent. Can you see that? X centimeters. So, as a rule of the thumb, we state the theorem, which states that hypotenuse squared equals opposite squared plus adjacent squared. So, put in what we know. Our hypotenuse is 10 centimeters, so we take the square. 10 squared equals our opposite squared is 6, our opposite is 6 centimeters. So we take the square, we have 6 squared plus the adjacent is x centimeters. So take the square of the adjacent, that's x squared. So let's calculate the squares. 10 squared is 10 times 10, which gives 100, equals 6 squared is 6 times 6, which gives 36, plus x squared. Then, remember, what we're looking for is x squared. So we have to make, we're looking for x rather. So we have to make x stand alone. So the first thing to do here is to get rid of this 36 by taking 36 from both sides, or subtracting 36 from both sides. So if we subtract 36 from both sides, on the left hand side of this equation, we're going to have 100 minus 36, because we're taking 36 from both sides, and we'll also remove 36 from the right hand side, so we have 36 minus 36 plus x squared. Then we calculate 36, 100 minus 36 gives 64, and 36 minus 36 goes to 0, plus x squared is still x squared. And we can swap sides. Since we have the equality sign there, which shows that 64 equals x squared. This also means that x squared is also equal to 64. So 64 equals x squared can also be written as x squared equals 64. So like we did in the previous example, what we are after is x, the value of x, and not x squared. So we have to take the square root of both sides. So rooting both sides, we have square root of x squared equals square root of 64. Square root of x squared gives x, and square root of 64 is 8. Please, you change that to 8. That's a typographical error. X equals 8 centimeters. So the value of the adjacent side is 8 centimeters. I believe you've understood that. Now let's move to what we call Pythagorean triples. Now the converse of the Pythagoras theorem is that if the square on one side of a triangle is equal to the sum of the squares on the other two sides, then those two sides contain a right angle. That's the converse of the Pythagoras theorem. Any set of numbers that satisfies Pythagoras theorem is referred to as Pythagorean triples. Now let's go back to the previous example. Let's take this example. Now you can see that the value of the hypotenuse, which we found as y equals 13, the hypotenuse there is 13 meters, while the opposite is 5 meters and the adjacent is 12 meters. So if we take all these numbers individually, this gives what we call the Pythagorean triple. That is, the Pythagorean triple in this diagram will be 13, 5, and 12. So that's what we'll be looking at in this section. So the examples of such set of numbers are 3, 4, 5, 5, 12, and 13, 8, 15, and 17, etc. And their multiples are also examples of Pythagorean triple. So now let's see how to check if a set of numbers is a Pythagorean triple or not. So the example here we have here is, which of the following set of numbers is a Pythagorean triple? Now, number 1 we have 3, 4, 5, 2. Number 2 we have 5, 7, and 8. Number 3 we have 7, 9, and 12. Now, the number 3, 4, and 5 is a Pythagorean triple if the sum of the squares of the adjacent and the opposites equals the square of the hypotenuse. So now let's check. Let's square 3 and 4 and take their sum and see if it will be equal to the square of 5. So we have 3 squared plus 4 squared equals 5 squared. Now these numbers are gotten from this set of numbers which was given in the question. So we pick the first number there, 3, we square it, we add it to the square of the next number 4 and equate it to the square of the third number. The third number is our hypotenuse. The first is the opposite, the adjacent, followed by the adjacent, then the hypotenuse. We put it in that order to see if what you have on the left hand side equals what you have on the right hand side. So now 3 squared gives 9, that's 3 times 3 equals 9, plus 4 squared is 4 times 4, which is 16. On the right hand side, 5 squared is 25. Now let's sum 9 and 16. What do we have? We have 9 plus 25 gives, 9 plus 16 rather, gives 25. And 25 equals 25, which is true mathematically. So therefore, the set of numbers 3, 4, and 5 is a Pythagorean triple. And let's look at the next example. We have 5, 7, and 8. 5 being our opposite, 7 as our adjacent, and 8 as our hypotenuse. Let's put it in this form in our Pythagoras theorem. We have the square of 5 plus the square of 7, equating it to the square of the hypotenuse, which is 8. So 5 squared is 25, and 7 squared is 49, 8 squared is 64. Now, summing 25 and 49, what do we have? We have 74, which is not equal to 64. You can see 74 is not equal to 64. So now, since 74 is not equal to 64, that means that the set of numbers 5, 7, and 8 is not a Pythagorean triple. So when this equation is not balanced, then we say those set of numbers are not a Pythagorean triple. So lastly, the last example we have here. Now let's check and see if this set of numbers 7, 9, and 12 is a Pythagorean triple. We repeat the same process. We take the square of 7, add it to the square of 9, and equate it to the square of 12. So 7 square gives 49, 9 square gives 81, and 12 square gives 144. Now let's sum 49 and 81. What are we going to have? 49 plus 81 gives 130. And 130 is not equal to 144. So since 130 is not equal to 144, it then means that the set of numbers 7, 9, and 12 is not a Pythagorean triple. So that's how you check if a set of numbers is a Pythagorean triple or not. So I believe this was understood. If there's any question, you can ask in the respective platforms you have. You can also send your questions personally to me. So for your assignments, you have the questions on your screen. Make sure you do your assignments and submit to me. If you have any question, like I said, you ask. Thank you for watching and have a beautiful day ahead.